Myself, Dr. Ashok Kumar, PhD in Composite Materials. So in the previous video, we discussed problems on the principal stresses. Two problems we have already solved. Now we are going to solve one more problem in the same chapter. This is the problem given by in the book. A bar of cross section 25 mm into 2.5 into 2.5 mm is subjected to an axial pull of 20 kilonewton. Calculate the normal stresses and shear stresses on an inclined plane which makes an angle of 30 degree with the axis of the bar. Also determine the maximum shear stress. So this is the problem given on the principal. So you can draw the diagram first like this. Sometimes you will give the same diagram in the question paper also. So sigma x on both sides, theta, and shear stress is acting like this and normal stress is acting like this. So area will be 25 into 25, 625 mm square. So pull will be around 20 kilonewton, 20 into 10 raised to 3 Newton. So angle made by the plane with the vertical will be always taken 90 minus 30, that will be 60 degree. So direct stress, you can use a simple formula, sigma x equal to F by A, 20 into 10 raised to 3, convert into Newton, divided by 625, you will get 32 Newton per mm square. Normal stress on inclined plane, sigma theta equal to sigma x into cos square, 32 into cos square 60, you will get 8 Newton per mm square. So shear stress on an inclined plane is given by tau theta is equal to sigma x by 2 into sin 2 theta. So 32 by 2 into sin 2 into 60, you will get 13.856 Newton per mm square. So maximum stress is always taken as half of the direct stress, that 32 by 2 16 Newton per mm square. So this completes the problem. So same thing we will solve one more problem on the principal stresses. This is the problem. The principal stresses at a point in a bar are 100 Newton per mm square tensile and 80 Newton per mm compressive. Determine the normal and tangent stress on a plane inclined at 60 degree to the axis of the major principal stress, and also find the maximum intensity of shear stress in a material at that point. So this is the diagram. Principal stresses, direct stresses are given 100 Newton per mm square, 80 Newton per mm square, 80 Newton square. So sigma x, sigma y, angle will be always 90 minus 60 with the vertical, that is 30 degree. You can use normal stress first, sigma theta equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta. So 100 plus 80 by 2 plus 100 minus 80 by 2 cos 2 into 30 will get 85 Newton per mm square. Shear stress on inclined plane Mn will be given by tau theta equal to sigma x minus sigma y by 2 sin 2 theta. So that is equal to 100 minus 80 by 2 sin 2 into 30 by 2, that will get 77.44 Newton per mm square. So maximum shear stress will be given by tau max equal to sigma x minus sigma y by 2. So 100 plus 80 by 2 will be 90 Newton per mm square. So that completes the problem. So now the last problem is given by determine the principal stresses and the maximum stresses in a bar subject to the following stresses. He has given sigma x 100 megapascal, sigma y minus 25 megapascal, sigma x equal to minus 75 megapascal, tau x by 25 megapascal, tau y z equal to 50 megapascal, tau x z equal to 75 megapascal. You can use the cubical equation here, sigma cube minus a sigma square plus b sigma minus c equal to 0. So a will be given by sigma x plus sigma y plus sigma z, that is 100 minus y will be 20 minus 25 minus 75, this will become 0. So b is given by sigma x sigma y plus sigma x sigma z, sigma x sigma y sigma z minus tau square xy minus tau square xz minus tau square yz. So substitute all the values, sigma x sigma y sigma z, you will get 16875 you will get the value. So c is given by sigma x minus sigma y sigma z minus 2 tau xy tau yz tau xz minus sigma x tau y square z minus sigma y tau square xz minus sigma x tau square xy. So substitute all the values, sigma sigma z, you will get 62 by 500. So substitute all the values, you will get a cubical equation here. So sigma cube minus 16875 sigma minus 62500. You solve the cubical equation, you will get sigma 1 sigma 2 and sigma 3. Sigma 2 will get minus 128, sigma 3 will get minus 375, and one more is sigma 1 and sigma 1 will get around minus 128, sigma 1 will get minus 128, right, and sigma 2 will get minus sigma 1 will get 131.75, sigma 2 will get minus 128, and sigma 3 will be minus 3.706. So for that you calculate tau max, sigma 1 minus sigma 2 minus sigma 3 by 2 minus 128 plus 3 sigma 3 will be 3.7 by 2, you will get 62.5. So like that tau max 1, tau max 2, you can calculate tau max 3 also by using different formula. You will get the shear stresses in 3 different value, tau max 1, tau max 2 and tau max 3. Thank you one and all, thank you.